you have read four different parts of processing data. One is fetching, second is decoding, third is executing, and fourth is storing. Okay, so each part is independent part. Execution. So there are four parts. One is fetching, second is decoding, third is execution or executing, fourth is storing. So four parts are different parts. So if storing part is going on, why not use other three parts meanwhile? Because if storing is going on, three parts of the processes are already idle. So if you use that three in parallel, let those four in parallel, you can speed up your process. So actually that is the pipelining concept. Clear? So instead of waiting for a full cycle to complete, you immediately start another instruction. Processor start another instruction instead of letting the already going on process to complete. So it is a technique in which CPU fetches the next instruction before it completes. Clear? The machine cycle for the first instruction. So clear, I have already explained in simple words. It is already written there. Faster processing and increase the performance of the computer. So what is the impact? It actually uh, speed up the process. And while first cycle completes, almost second cycle is ready to complete. So that's how it increases the performance of the computer and faster the processing speed. Second, without pipelining, the processor fetches, decodes, execute, and store only one instruction at a time. So by using pipelining, you actually run more than one cycle at a time. The CPU wait until an instruction completes its all four stages and then execute the next instruction. So that is the conventional method. In pipelining, you actually parallelize the whole instruction or the whole process. So pipelining is clear. Any confusion? कौन से third point की? So without pipelining, for example, I have given you a simple example that 100 is less than 99 or 99 is greater less than 100 is greater than 99 or 99 is less than 100. Same question for two different classes with different style. So without pipelining, the processes fetches, decodes, execute, and store. So there are four parts. One is fetching. Second is decoding that instruction to get commands. Third is execution of the instruction, like 100 is greater than 90. So that the whole thing is implemented in execution process, and then storing that to memory, into the memory. So if an instruction is waiting till all four stages completes, then that is the conventional method before pipelining. So it wastes time and energy at the same time. So instead of letting one cycle to complete, the processor starts another cycle or another instruction to complete. Clear? So that's why without pipelining, the processor fetches, decodes, execute, and store only one instruction. While using pipelining, you can process more than one processes at the same time. So what is system clock? You have seen that your processor clock is that much hertz, or your processor actually process the frequency or the measurement you do usually the processor that megahertz or that gigahertz processor. Clearly, so it actually represents the clock speed. How many instruction, how many cycles, or how many frequency it has in 1 second, or how many instruction it can fetches at one time, single time. So I have already given you an assignment, I guess, regarding your CPU and all that. Clear? So you already know what does that mean, that gigahertz and megahertz and all that kind of thing. Clear? So it is an electronic component, you all know. The system clock controls the timing of all computer operations, control all the function of computer. So actually, different parts of computer actually synchronize to that clock. Clear? And actually, computer perform all the instruction by following that clock. So by that clock, computer knows that which instruction is going on. Either instruction is completed and or an instruction to be started, because so the digital clock is like this. The signal is like this. On, off, clear. So this is the beginning and this is the ending of a simple cycle. Clear. So that is a digital signal. We have already discussed that. Clear. So it is actually generate electric signal at a fast speed. So for example, if a clock speed is 1 gigahertz, it means in 1 second there are 1 gigahertz cycle repeats. Clear? What is giga? Giga means 10 raised to the power. Mega means 10 raised to the power 6 and giga means 10 raised to the power 9. So that much cycle in 1 second is the speed of clock. So you can think or you can imagine how faster it goes on, goes up and goes down. So tick of system known as clock cycle. Ticking means the on off or the cycle up and cycle down. Ticking. You have heard the ticking of your wall clock. It is tick tick tick. That word is actually taken from there. Tick of system known as clock cycle. And set the speed of CPU. Computer clock can tick from millions to billions time in 1 second. If a speed is 1 gigahertz, so it means that is billion. And if clock is in megahertz, it means that is million. What is billion? 9 zeros, so 10 raised to the power 9, right? One, and how about million? 6 zeros, so 10 raised to the power 6. Clear? So system clock is a factor that affect a computer speed. So if you compare today's computer to the computer earlier, like around 1 decade before, 10 years before. So the speed was limited. That was kind of Pentium computer. No, the system are in higher generation, 10th generation, 11th generation. So the clock speed is increased. So processor actually increases its clock speed with time by the manufacturer. If it balances the cost. Clear? Any confusion with that? Every circuit actually, digital circuit needs that clock speed. So if you have seen the different devices like an Arduino or Raspberry Pi, some of you might already be using that or thinking of to use that. So that's a kind of digital computer also uses clock, or oscillator or some kind of that thing. So then by this clock, there are two different terms emerged. One is MIPS and second is flop. So sometimes you heard that you hear that speed of our, like for example, the speed of our HPC is 91 teraflops. Clear? So it represents the calculation. Second, you have MIPS. So MIPS means million instruction per second. So MIPS stands for million of instructions per second. If a speed of computer is 1 MIPS, it means 1 million instruction is processed in 1 second. Clear? So it actually shows the speed of workstation in some server computer MIPS that is measured in MIPS. And second is floating. Flops are the floating point operation per second. So what is floating point? Floating point mean, yes, decimal or float. You have already heard the word float, integer and float. It means you can see the accuracy in terms of after the 1/10 part or 100th part after the point. We usually say that अशारे के बाद जो आते हैं, that is actually floating points. So actually supercomputers on high performance computer is measured in flops. So the speed of our on or this institute high performance computing cluster is 91 teraflops or 97 teraflops. There's a bit confusion. So you can measure the speed that 91 tera. So what does tera mean? 10 raised to the power 12. So it means 91 into 10 raised to the power 12 flop operation performed in 1 second. Clear? Flops क्या है? Floating is floating point operation per second. So floating point actually used for the accuracy. So the digit after point is usually included in floats. That is a kind of measurement unit. You can measure, plotting numbers. So flop is actually, for example, the speed of our own HPC is 91 teraflops. So it means 91 multiplied 10 raised to the power 12 plotting operation per second. Uh, CPU contains special storage areas called registers. So for instant calculation or for instant fetching of information, storing information, you CPU use registers. ये CPU के अंदर होते हैं, CPU चिप के अंदर होते हैं, ठीक है. तो CPU itself एक कंप्यूटर है उसमें, क्योंकि वो सारी चीजें कर रहा है, कैलकुलेशन कर रहा है, स्टोर कर रहा है. तो एक मदरबोर्ड है, उसके अंदर आपकी मेमोरी रैम लगा हुआ है, आपका यस मदरबोर्ड होता है. बट जब आप सीपीयू की बात कर रहे हैं, जब आप मदरबोर्ड कहते हैं तो इट डजंट लुक गुड कि आप मदरबोर्ड कहें. ये ऐसा ही है कि आप कहें कि कंप्यूटर से मुराद वो स्क्रीन ही है ना. तो जब आप एडवांस उसमें जाते हैं क्लासेस में तो आप बड़ा स्पेसिफिक जाते हैं. यस मदरबोर्ड में होते हैं. So their function is to hold instructions. You know the instructions, right? So fetching of instructions. Data values, for example, 199. Okay. Memory addresses, memory has their own addresses. When the processor processes a data, it stores its certain area. So that location has specific values. Based on that values, the data is stored on that area. So you are doing your C programming or C+ programming. Have you used pointers? No, not yet. So when you will study pointers, you will understand the concept of memory addressing. So from pointers, you point to that memory where your data is stored. Clear? So memory addresses are both the instructions and data. So memory stores data, memory addresses stores instructions and data. So register size determines how much information it can be stored. I don't know the exact register size of a CPU, so it will be very, very specific if you ask me that question. Just search that. The size of registers is in bytes. In bytes, what is a byte? 8 bits. Then what is bit? Single information or single representation of on or off. Okay. So bigger size of register increase the performance of CPU. So if you save or process large sum of data or large size of register data, then it will speed up your performance or calculation. Clear? So data representation, we usually represent data in two forms, conventionally analog and digital. Analog signals are continuous and vary in strength and quality. ठीक है, तो depends upon the representation कि वो कैसे उसको represent कर रहा है. And digital signals are in one of two states, either one or off. I have already drawn a digital signal for you, right? So that was actually a digital signal. So most computers these days use digital signal or digital representation of a signal. The binary system uses two unique digits, 0 and 1, and that is called a bit. So this is actually, if you look at your window, computer screen, a computer circuit represents the 0 or the 1 electronically by the presence or absence of an electric charge. So if there is an electric charge in a computer circuitry or electronic circuitry, it is represented with either 1 if there is an electric signal and 0 if there is no electric signal. Clear? So you see, you have buttons in all over your house, in your room. So mostly there is written straight line represented represent 1 and 0, that is represent 0. It means power on or power off. Clear? And computer screen, you see both on and off is written together like this way. Yes. Okay, so this is actually on off. ये मैंने पहले भी कहा था, लेकिन फिर भी नहीं पता आप लोगों को. ठीक है. So if so light, this light means there is electric signal, so that is on. So when we off it, there is no electric signal. So it means electronic charge is represented by this symbol. And electronic state, so the on and off is a state. Signal presence and absence is shows electronic charge, and binary digit is represented by 0 or 1. So three different states. So it's three different representation. Clear? So when 8 bits group together, it is called single byte. Clear? A byte represents a single character in the computer. So the ASCII code, we will read in forward slides. So different combination of zeros and ones are used to represent different character or different meaning or different message. Clear? Data is converted to binary form before it is stored inside the computer. So actually, computer stores data in binary information. So for example, if you want to save your name XYZ, so that is converted into binary in the form of zeros and one and stored somewhere in your computer addresses. So computer doesn't know what is XY, what is one, what is, yeah, it knows what is 1 and what is 0, but doesn't understand 3, 2, 4, 5, 6, 7. The process of converting data into binary form is known as encoding, a form of encoding. Clear? Representation of all numeric and non-numeric data in binary digits is known as computer code. So computer stores that information in a code or representation or meaning. Clear? Different coding scheme are used to represent different characters. So actually, then there comes the coding scheme, which sequence we use for which character, and so that kind of representation is called coding scheme. Clear? You have already seen one MCQ about the keyboards save data or process data in terms of which one. So I guess most of you have answered that question. It was Ascii. So one coding scheme is called BCD code. That means binary coded decimal. Have you ever convert a digit or value to a binary? No? Okay. Okay, so for example, this is actually to count from right. Okay, how many zeros are there? 1 to 5. And each the power of each digit is equal to this way. 2 power is 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Starting from 2 power 0. So we will remove this one. Okay. So if you want to represent 1, that it means you need to turn on this digit. All others are off. Clear? If you want to represent 2, so it means on this one and off other. If you want to represent 3, then you need to turn on, it is actually summation. Count this. If you want to represent 3, turn on this because it is 2 and turn on this because this is 1. So 2 plus 1 equal to 3. So 3 is represented this way. Clear? If you want to represent 7, so it will be written like this way. Power 0, 2 power 1, 2 power 2, 2 power 3. So it is actually 1, this is 2, this is 4, this is 8. So sum of all this is 7. So it will be 0, 1, 1, 1. Clear? Clear? Now you understand how it is coded. Because of what? This is 0, this is 1, this is 2. This is actually. So 2 power 0 means anything power 0 equal to 1. 2 power 1 means 2. 2 power 2 means 4. 2 power 3 means 8. Okay. So I will remove this one. Clear? So this is actually the power of this digit is actually 1. Power of this digit is actually 2. Power of this is 4 and this. So now, if you want to say any value between 0 and no, it means 8 plus 7, 15. So any value between 0 and 15 you can represent from this value. If you are using decimal system, there is another system which is called hexadecimal. So then the representation of that system is different. For example, in hexadecimal, 10 means A, and but in this system, 10 means 10. Clear? Decimal 10. Okay, so if you want to represent 7, we are going towards that. Just I want to explain this more because it is your future. You will learn, you are talking 8, so it will be equal to 1000. This is 8, and 15 is equal to 15, and 6 equal to 0, 1, 1, 0. Because some days 4 plus 2 is equal to 6. So the 2 in between. So you see, so it is stands for binary coded decimal, represent decimal digits from 0 and 1. 4-bit code. 4-bit code means each decimal digit is represented by 4 binary digits. Clear? Used by early computers. So this scheme was used by or is used in early computer. Okay, 0 represented by 4 zeros. 1 is clear. अगर आप इधर देखें तो 9 is represented by 1 0 0 1 and so on and so forth. 3 is represented by 1 1. Clear? ये coding scheme आपको समझ आ गई? Clear? I will give, for example, this is convert decimal is 5 to 4 to 5 to BCD. How you convert? 4 is 0 1 0 0, 2 is 0 0 1 0, and 5 is 0 1 0 1. So that is written over there. You just need to practice. So actually you combine this. This is actually so actually computer uses ASCII codes to send message or to input some data. So it is stands for American Standard Code for Information Interchange, published in 65. So you can think it was emerged in 1968, around 80 years or 60 years, by Ansi, American National Standard Institute, ANSI. So widely used in personal computers. So ASCII code is actually represented in, by 7 bits. So 7 bits means 2 to the rest of the power 7 different information can be stored. So can you give me what is 2 raised to power 7 means? It is already written. 128. So it starts from 0. So 0 till 127. How about 2 raised to power 10? Huh? So where have you read that, or you just calculated? With if you think somebody is genius without memory, then I don't think so. It is sometime kind of. So actually, data is also important for your processing. See, processor is your. When somebody asks me, so I tell them that my RAM is weak, but my processor is speed. I actually say about myself. So it means if so, your mind is actually or your behavior is actually a kind of computer. You need RAM and you need processors. So processor means you instantly answer something, and memory means your previous knowledge. Okay. Yes. So if you do not have memory or you do not have sufficient knowledge before, then if you have highest performance, then it doesn't matter. Okay. Okay. So for high performance, you need good memory and good processor. Okay. So if one has one less, then it means he cannot compete. So most computers, मेरे ख्याल में आप लोगों को समझ आ गई होगी क्या आपको मेमोरी की भी जरूरत होती है, रैम की भी जरूरत होती है और आपको प्रोसेसर की भी जरूरत होती है. तो आपने जब काम करना है ऐसे नहीं कि आप सोए मेरा प्रोसेसर स्पीड तेज है तो मैं परफॉर्मेंस नहीं आती जब तक आप क्या रैम और आपका प्रोसेसर दोनों साथ न रहें. ठीक है. It is true also true about yourself. Most computers typically reserve 1 byte or 8 bits for an ASCII character. Okay, 7 bits से represent होता है, but computer 8 bit data उसके लिए reserve रखती है. ठीक है. Now it is extended to, so it is actually extended to 128 unique code represent graphic symbol. So have you seen that there are numeric values, alphanumeric values, and special characters? Okay. For example, smileys or something like that, or your dollar sign, your hash sign, your asterisk sign. So there are different codes are assigned for each character. So for example, for capital A, so there is also distinguish between capital and small letter. Clear? So that's why when you write a password, with capital letter it doesn't work because code is different and it is, you know, from A to Z it is represented by from 65 to 90 क्योंकि 0 1 से कोई और करेक्टर स्टार्ट हो गया होगा, ठीक है। क्यों वाले आंसर की तरफ आप लोग ज्यादा चले जाते हैं और जो लिखा हुआ है वो आप लोग को उसके बारे में आप नहीं करते। जो इन्फॉर्मेशन लिखी हुई पहले उसको तो आप लर्न करें, ठीक है, क्योंकि ये सारे कोड आप लर्न नहीं कर सकते। इसका कोड क्या है आपको हमेशा टेबल ही रखना पड़ेगा उसको याद करने के लिए। बट ये है कि ये इजी है ना, A to Z आप सबको याद है तो 65 से स्टार्ट है और 90 पे एंड है। तो इसका मतलब है कि अगर कोई ASCII वैल्यू आपको नजर आए तो आपको पता चल सकता है कि ये रिप्रेजेंट कर रहे हैं किसी पासवर्ड को। So that is actually information, getting information from coded word, okay? But ASCII में नहीं होती चीजें, इस चीज से इंफॉर्मेशन ट्रांसमिशन होती है। इसके लिए बड़े एनक्रिप्शन टेक्निक यूज होती है जिसमें आपके पासवर्ड्स जो है, अगर प्लेन इसको कहते हैं ना कि अगर प्लेन वर्ड में आपका पासवर्ड सेव है तो वो ASCII में होगा, बट अगर वो किसी को इनकोड हुआ होगा किसी और एनक्रिप्शन टेक्निक में तो वो किसी और मतलब उसका बाइनरी कोई और होगा, so you can not detect easily, ठीक है। स्मॉल वर्ड जो है 97 से स्टार्ट है, तो 90 तक आपके कैपिटल हैं और फिर 97 से आपका स्मॉल कैरेक्टर स्टार्ट है। और उसका आंसर मेरे पास नहीं है कि 90 से लेकर 96 तक क्या है, वो आप सर्च कर लेंगे वो किस चीज के। टेबल देख ले गूगल पे कि 0 और 1 से कौन से स्टार्ट हो रहा है, आप ASCII टेबल लेके तो आपको पूरा एक आ जाएगा, ठीक है। 0 और 1 जो है 0 और 9 जो है 48 से स्टार्ट है। प्लीज चेक गूगल कर ले कि क्या क्या। तो अगर आप देखें ये साइन जो है क्वेश्चन मार्क, इसका जो कोड है वो 63 है, डॉट का 46 है, इक्वल का 61 है। तो जो आपको मैं बता रहा था कि आपने अगर 10 + 20 इक्वल करना है तो वो मैसेज आप दे रहे हो कि 10 का भी ASCII दे रहा है, प्लस का अलग अलग ASCII है, 10 का अलग है, इक्वल का अलग है। तो एक्चुअली प्रोसेसर आपका इन्हीं चीजों से डिटेक्ट कर रहा होता है कि मैंने क्या करना है अब, ठीक है। ब्रैकेट्स के अपने होते हैं, ओके। सो देन ASCII जो है वो ASCII was or is extended into extended BCD बाइनरी कोडेड डेसिमल इंटरचेंज कोड। ये 8 बिट का कोड है। इट इज डिवाइडेड इनटू 2 ग्रुप्स ऑफ 4 बिट्स। 8 बिट्स है तो 4 बिट्स का अलग अलग उसकी ग्रुपिंग की गई है, ठीक है। ईच ग्रुप कैन रिप्रेजेंट 1 हेक्साडेसिमल कोड। जैसे मैं आपको भी बता रहा था, एक और हमारे पास सिस्टम है उसको हेक्साडेसिमल सिस्टम कहते हैं, ठीक है। तो ये जो EBCDIC कोड है या एक्सटेंडेड वर्जन जो है BCD का, that is actually represented as 4 bits, ठीक है, और represented by 8 bits used in mainframe computers, ठीक है। खैर ये तो एक एप्लीकेशन है। तो अगर आप देखें 2 पावर 8 कितना होता है, 2 पावर 8 आप बताओ। अच्छा वो याद था, प्रोसेसर वीक हो गया, रैम 256 ऐसे 1 1 2 4 8 16 32 64 128 256 5 12 and 1024 and 2048। तो ये आप लोग याद कर लो, ये तो आप लोग, ठीक है। तो ये जो स्कीम है इसके रू से आपका जो हेक्स कोड है इसको हेक्स कोड कहते हैं। जैसे मैंने आपको कहा C0 रिप्रेजेंट कर रहा है, हेक्साडेसिमल में आपका 0 to 1 होता है एंड देन A B C D E F। ये 10 को रिप्रेजेंट कर रहा होता है, 11 12 13 14 और 15, ठीक है। तो C0 का मतलब है कि ये डिजिट जो कि 10 11 12 12 कैसे रिप्रेजेंट होगा, 12 ऐसे रिप्रेजेंट होगा, 8 बिट ऑन होगा और 4 बिट ऑन होगा। तो ये आपके पास क्या हो गया, C हो गया, ठीक है। और 0 तो आपके पास C होगा, तो इसका जो कोड है वो ये होगा, ठीक है। ये आप लोग आगे क्लासेस में भी पढ़ेंगे, मैं आपको जस्ट जनरल आइडिया दे रहा हूँ। अच्छा 0 to 9 तो सिमिलर है, ठीक है। फिर आपके पास जो 10, 11, 12, 13, 14, 15, आपको पता है कि आप 4 बिट से क्या रिप्रेजेंट कर सकते हैं मैक्सिमम। जब सारे ऑन होंगे तो वो काउंट कर रहा होगा 15 को। तो यूजुअली ये लिखा नहीं जाता क्योंकि ये मिक्स हो रहा है 0 to 9 में, ठीक है। तो 0 to 9 में मिक्स हो रहा है, तो इसका मतलब है कि 2 डिजिट रिप्रेजेंट हो रहा है 4 बिट्स का। तो उन्होंने इसका हल ये निकाला कि 9 के बजाय ABCDEF तक होगा। F रिप्रेजेंट कर रहा होगा आपके 15 को। क्लियर है? अब अगर ये कोड लिखा हुआ है तो इसको उन्होंने कह दिया 10 को ABCDEF। क्लियर है? अब अगर ये कोड लिखा हुआ है C0 तो आपने इसको, आपको पता है कि C क्या है, 10, 11, 12। 12 को आप बाइनरी से कैसे रिप्रेजेंट करते हो? 8वां बिट ऑन करे और 4था बिट ऑन करे और तीसरा बिट ऑन करे। 1 1 0 0 काउंट क्या होता है? 1 2 4 8। तो 4 और 8 जमा करके क्या हो गया? 12 हो गया। C है। और 0 तो 0 से रिप्रेजेंट हो रहा है। तो जो एक्सटेंडेड कोड है वो एक्चुअली इस तरह रिप्रेजेंट हो रहा है। क्लियर है? आप किसी को समझ नहीं आई? अच्छा, तो अगर आप इसको देखें तो 0 जो है वो 0 इज रिप्रेजेंटेड बाय F0। तो ये इसका कोड है एक्चुअली। 0 जो कैरेक्टर है उसको F0 से रिप्रेजेंट किया है इस कोडिंग से। सिमिलरली अगर आप ब्रैकेट देखें, ब्रैकेट्स क्लोज, तो वो D0 से रिप्रेजेंट हो रहा है, ठीक है। D0। सिमिलरली जो आपका A है वो C1 से रिप्रेजेंट हुआ है। हमारे बिल्डिंग का नाम भी C1 है, ठीक है। तो जो आप कह लें कि वो A। C2 जो है आपका B है। चलो इस बिल्डिंग का A2 इस बिल्डिंग का नाम है, उसको आप कोड कर लें, बाइनरी में कन्वर्ट कर लें A2 को। कन्वर्ट A2 टू बाइनरी, दिस कोडिंग स्कीम। नो A2, अभी आप A2 में हो ना, A2 को इस कोडिंग स्कीम के लिहाज से कन्वर्ट कर ले बाइनरी में। A2 4 डिफरेंट बना ले ग्रुप, 4 बिट्स से रिप्रेजेंट करें। कौन पहले देगा? A2 आपके पास कन्वर्ट दिस वैल्यू। इसको एक्सटेंडेड वर्जन में कन्वर्ट कर ले, एक्सटेंडेड कोडिंग हो गया। 10 और 2, ठीक है। कौन से वाला? ये तो नहीं है, 4 बिट का गलत है। 4 बिट है ना। A2 को करना है तो 8 टोटल बिट्स आपके 8 होंगे। हाँ ठीक है, ये ठीक है। सी नहीं, A2 A and 2 मैंने लिखा भी है ना, A2। अच्छा, आप लोग जब MS वर्ड कर रहे थे तो जब आप स्पेशल कैरेक्टर में जाते हो ना, तो उसको आप चूज करते हो कि मैं यूनिकोड में सेव कर रहा हूँ या किस में कर रहा हूँ। तो वो एक अलग कोडिंग स्कीम है, ठीक है। तो जो आप MS वर्ड में जो आप लिख रहे होते हैं वो एक्चुअली एक कोड के पीछे सेव हो रहा होता है, डिकोड होके इनकोड होके वो सेव हो रहा है किसी मेमोरी एड्रेस में। तो जो यूनिकोड होता है वो एक्चुअली 16 बिट्स कोड को रिप्रेजेंट कर रहा होता है। ASCII 7 को कर रहा था, एक्सटेंडेड 8 को कर रहा था, एंड यूनिकोड 16 को कर रहा है। तो ये कितने बिट्स को रिप्रेजेंट कर रहा है? 65536। 2 रेज़ टू द पावर 16 जो होता है वो 65536 होता है। ये कैसे आ गया? 2 रेज़ टू द पावर 1024 होता है, और आपका 6 जो होता है वो क्या होता है? 625 होता है ना। 2 रेज़ टू द पावर 6 क्या होता है? बट ये इस तरह नहीं है, ये अलग तरीका है, ये अलग तरीका है सर, समेशन वाला है नहीं। 2 रेज़ टू पावर 16 आप कर ले, कैलकुलेट कर ले कैसे है, ये वैल्यू आती है कि नहीं आती? 2 रेज़ टू पावर ठीक है। So this code actually started to replace ASCII code because it can be coded for more characters, and you can encode that much character in this. So that is used for like for Roman Urdu, for English, for Spanish character, for Chinese character, and all that kind of character are actually special character code for each character. So multilingual coding scheme is emerged or given. जी कुछ क्या पूछ रहे थे, भूल गए पूछना. Actually इधर लिखा भी हुआ है जो मैं बता रहा हूँ. Represent the character of all languages in the world. So दुनिया में जितनी लैंग्वेज है उसके हर किसी के लिए, जैसे उर्दू के हैं अलिफ बे थे से शे या अलिफ बा ता सा जीम, तो आप जो है उसको एक रिप्रेजेंट करने के लिए कोड यूज होता है ना, ठीक है. और सिमिलरली पश्तो का देखें, और सिमिलरली आप रशियन देखें, चाइनीज देखें, अलग कैरेक्टर होते हैं उसके. कोरियन देखें, हर कैरेक्टर के लिए एक कोड है जो कि उस कोड के बेस पे, अगर आप फॉर एग्जांपल अगर आप कीबोर्ड में उर्दू में लिख रहे हैं या आप अपने मोबाइल में उर्दू में मैसेज टाइप कर रहे हैं, तो उसके पीछे एक कोडिंग स्कीम होती है जिसको यूनिकोडिंग कहते हैं, ठीक है.